We're going to talk about percent composition of a compound today. And what we mean by percent composition is relative amounts of the elements in a compound expressed as a percent composition. We're talking about percent by mass of each element in the compound. So like I was saying earlier, H2 is 100% by mass hydrogen. But H2O, I'll give you a really simple one, it has 2 hydrogens plus 1 oxygen, right? Its molar mass is 18 grams per mole. Now, 16 of those grams is oxygen, and only 2 of those grams is hydrogen. So even though hydrogen outnumbers oxygen 2 to 1 in water, the oxygen is actually a much higher percentage of the composition when we're talking about mass. Okay? Everybody got that? So moving along, let's have a look at this compound right here. The compound is potassium chromate. 2 potassiums, 1 chromium, and 4 oxygens. Okay? Looking at this pie graph, you can see that it's mostly potassium. It's 40% potassium. It's only 27%, roughly, chromium, and the balance, almost 33%, oxygen. Okay? One thing you need to know about percent compositions, I have them written right here. If you add them together, what should you get? 100%. Exactly. Well, that's your check right there. When you've done a percent calculation, a percent composition calculation, you can add all those percents together, you will get 100%. Now, different compounds, even if they're made up of the same elements, if they're different compounds, meaning they have different numbers of each element, they will have a different percent composition. And here's an example. This is our previous example of potassium chromate. We also have potassium dichromate. 2 potassiums, but instead of 1 chromium, you have 2 chromiums, and you have 7 oxygens instead of 4 oxygens. And as you'll notice, potassium is now a smaller percentage of the total. Okay? The composition of potassium dichromate is less potassium, more oxygen, more chromium. Everybody see that? These are 2 different ionic compounds. They have 2 different percent compositions by mass, even though they're composed of potassium, chromium, and oxygen. And again, all their percent compositions for a compound will equal 100%. Here is the operative equation that you'll need to learn to determine percent composition of a compound. If you have mass data, okay, meaning if you have 15 grams of a compound and 3 grams of it is element X, you can determine the percentage. And it's just the same of saying part, remember this, part over the whole. Part over the whole, that's percentage. And you multiply that by 100%. So if you want the percent mass of an element, you take the mass of that element and you divide by the mass of the compound, then you multiply by 100%, and that gives you your percent mass. Do you understand? We're going to do a practice problem together, or sample problem. This is sample problem 10.9 on page 326. A 13.6 gram sample of a compound containing only magnesium and oxygen is decomposed, meaning it's broken apart. We get 5.4 grams of oxygen. What is the percent compound of this, or percent composition of this compound? Now they gave us the total weight of the compound, or not weight, mass, excuse me. Okay? And they told us that oxygen mass was 5.4 grams. There's also magnesium in here. How will we determine the mass of the magnesium? If we know the total mass, and we know the mass of the oxygen, Then all we have to do is subtract the oxygen from the total to get the mass of the magnesium. There are 8.2 grams of magnesium. Simple enough. Next, we're going to find the composition, percent composition of oxygen. The percent composition of oxygen. Let's jump back real quick right here. Percent composition of oxygen will equal the mass of oxygen over the total mass of the compound times 100. So, percent by mass of oxygen will equal the mass of the oxygen, which I'm taking from above, that's right here, and the total mass, which is 13.6 grams. Multiply by 100, and that gives me percent oxygen by mass. And I'm not recording, am I? Maybe I am. Oh, I am. And we got 39.7, and that is in correct number of significant figures because we have 3 significant figures that we should have. Now let's do magnesium. The percent of magnesium in this compound is, let's use our 8.2 from up here. That's the part of this compound, which is magnesium, over the whole amount of compound, which again is 13.60 from above. That was given. Times 100 equals the percent of magnesium by mass. We check by adding. Let me do that in a different color just so we can see it. By adding 39.7, that's the oxygen percent, plus 60.3, and we get 100%. So we know that our answer is likely correct. Now, you could do problems number 33 and 34 on page 326. Okay, the second thing you can do with percent composition is that you can calculate percent composition from the chemical formula, okay? From the chemical formula. So what you do with this is you assume that you have 1 mole of the compound, okay? And when you assume that you have 1 mole of the compound, then you can determine how many grams of that compound you have, and you can determine how many grams of each element you have in that compound based on the formula, correct? So for H2O, for instance, back to my easy example, you know that the molecular weight of H2O, not the molecular weight, the molar mass is 18 grams per mole. And you know that you have 2 grams of hydrogen per mole, and oxygen you have 16 grams per mole. Now that's a simplistic example, but now we can use these 2 masses right here and our total molar mass and find a percentage as well, okay? Even though we don't know how many grams of this we have, we assume 1 mole, okay? And here's how we'll work a problem like that. This is sample problem 10.10 on page 327. Propane, which is C3H8, is used in gas grills. And this compound is obtained from a petroleum. They want us to calculate the percent composition of propane, and the only thing we have is the formula, C3H8. So the first thing we need to do is we should calculate, let's calculate the molar mass of C3H8, 3 times the molar mass of carbon, which is 12.0 grams per mole, plus the molar mass of the hydrogens in this compound, which is, there are 8 hydrogens, and the molar mass is 1.00 grams per mole, for a total molar mass of 36 plus 8 is 44 grams per mole of C3H8. Also in here, we have calculated the molar mass of the hydrogen, right? And the carbon separately. a molar mass of carbon is just this bit right here, 36.0 grams per mole. And the molar mass of the hydrogen is 8.00 grams per mole of hydrogen. What can we do with those numbers? Well, let's find the percent composition of carbon first. We take the part, which is here, 36 grams of carbon per mole. I'm going to write that differently, sorry. 36.0 grams of carbon per mole. And I'm going to put it over the total molar mass for propane. Where's the total molar mass of propane? Right here, 44 grams. So for every mole, or 44 grams of propane, 36.0 grams is carbon. Grams per mole of propane. Multiply by 100, and we will get a percent of carbon. Okay, moles cancel. And we'll get 81.8% carbon. Now let's see what percent hydrogen we have. Well, we have 8 grams right up here of hydrogen for every 44 grams of propane. So we got 8 grams of hydrogen for every 44 grams of propane. Multiply by 100, and you'll get your percent of hydrogen. And it should be about 18.2%. Okay, we have our percent composition for carbon and hydrogen, and they should total, when we add them together, 100%. And they do. So now you should be able to work 35 and 36 on page 327. Last thing we're going to do with percent compounds for now, or percent compositions, is we can actually use these as a conversion factor. If you actually know the percent composition, if you're given the propane is 81.8% carbon and 18.2% hydrogen like we calculated earlier, if you assume that you have 100 grams of propane without even using a calculator, can you tell me how many grams of carbon you're going to have? It's how percentages work. If I have 100 grams of this, that's 81.8% carbon, and that's 81.1 grams of carbon, right? We're just multiplying by 100. And how many grams of hydrogen would be in 100 grams of propane? 18.2 grams of hydrogen, okay? You see that? I'm assuming that I have 100 grams. Therefore, I'm automatically converting my percent into a number of grams. And I can use those as conversion factors to solve for the mass of carbon or hydrogen contained in a specific amount of propane. Here are my conversion factors. 81.8 grams of carbon per 100 grams of propane, because I'm assuming I have 100 grams of propane. And 18 grams of hydrogen over 100 grams of propane. Those are my two conversion factors. How could I use them? Let's have a look at sample problem 10.1 on page 329. And let's all work it together. Here we go. Calculate the mass of carbon and the mass of hydrogen in 82 grams of propane. Now, based on the previous example, sample problem, and the previous slide, we know the percent of carbon in propane is 80, let's go back and just make sure I got it, 81.8%. And the percent of hydrogen is 18.2%. Now, using those two things, let's do this. Let's assume that we have 100 grams of propane. Oops, that's 8. And if we make that assumption, then we'll have 8 grams of carbon in that 100 grams of propane. We'll also have 18.2 grams of hydrogen in that 100 grams of propane. Right? That's what percentage means. If I say it's 18.2%, that means 18.2 grams per 100 grams, per 100. That's what percent means. It means per 100. So I have those two conversion factors, and they gave me 82.0 grams of propane. All I have to do is multiply 82 grams of propane. Grams of propane cancel, and I'm left with grams of carbon when I multiply. Do the same thing down here. I'm multiplying by 82. That's the actual amount of propane they gave me. Grams will cancel, and I'll be left with grams of hydrogen when I do the math. So when you do the math for each of these, and don't forget to divide by 100, 81.8 grams of carbon divided by 100 grams times 82 grams of propane, and you get 67.1 grams of carbon. Same thing, 14.9 grams of hydrogen. Last thing, we can check it by adding these two, and they should add up to the number of grams of propane that we were given. 82 grams of C3H8 checks out. So now that we've done that, you should be able to do problems number 37 and 38 on page 329.